Welcome to today's webinar, Requirements Development. My name is Katie, Communications Manager at Vitech, and I will be your host during today's webinar presented by Bethany Maddox. Bethany serves Vitech's customers primarily at the support desk as the customer care specialist. Between support cases, she manages the overall vision of customer care at Vitech, developing instructional screencasts on various core and Genesis topics and elements of software documentation. She has often served as host, writer, and technical manager of countless webinars throughout her tenure at Vitech. Before Bethany gets started, I do have just a few housekeeping items. We will be answering questions today at the end of the webinar. Please send your questions in as soon as you think of them through the question tab on your webinar control panel, and I will get them over to Bethany. The webinar is being recorded today. If you experience connection problems during the live presentation, a recording will be available within 24 hours of the live version. To view the webinar online, just log back into the My Support area of the Vitech website. And I will chat that link out to you now so that you have a record of it. Now I'm going to turn the presentation over to Bethany. Welcome and thank you for joining us.
Hi Katie, thank you. So today's webinar starts from the place of I've parsed in my requirements and now what do I do? I get this call sometimes from students and a variety of other people who are just getting started. So today we will start from a set of parsed requirements. We'll deal with the debris and then we'll examine each requirement to decompose it down to the leaf level, and we'll set a few attributes on the way. Then we'll learn a little bit about concerns and risks and work with one of each of those. So as we begin, I think it's important to touch on the intended audience for this webinar. Today's material is scoped for the beginning systems engineer. You might be a student or possibly an engineer in another discipline that's starting to do more systems thinking. I'll teach you just a little methodology and a little buttonology as we go. This webinar assumes that you have a set of source requirements. Maybe these come from a document or a spreadsheet. Maybe you sit down with your stakeholders to elicit them. If you don't have them yet, then you'll need to start with the task of collecting your stakeholder needs and transforming them into statements of required functionality and performance and design constraints. While the focus of this webinar is requirements, what I'm really talking about here is how to get your project started in core. I want to take a moment to have you capture a key element, and this is the component that represents your system of interest. Now, when you create a new project in core, a few seed elements are created for you. In the project you see here, I've created a new project, and it had some seed elements. These requirements, these 23, are what I parsed. And the document I created, but the one component, the one function, and the one state were all my seed elements. So let's take a look at the component class. Here you see the system context. The context is the environment in which your system lives. Your context contains, or is decomposed by, your system of interest and other components with which your system must interact. Let's create a component to represent my system of interest. Now, I like to work from the diagram palette, so to start, I'll open the system context element and view a structure BDD. Now, this is similar to a physical hierarchy diagram, and it's great when I want to see the relationships between the components. Now, I'm going to hold down the control key on my keyboard and drop new node from the right side onto system context. Now, this keyboard combination allows me to designate the name as you see here. If I didn't use this keyboard combination, Core would auto-name the component, component 1, and move on. Now, I'll go ahead and name my system element fast food restaurant. And click OK. Now we see the relationship between the system and the environment in which it lives. As I figure out more about the physical architecture of my system, I can come back here to capture that information. I'll particularly want to flesh out the interactions between my system and other components, such as suppliers of food to my restaurant or the customers. While I'm here, let's fill in a little bit of information about my system component. Now, I logically know the description and the mission of my system. But when I parsed in my source document, it gave me some great information. So let's go use some of that. Now while I'm here, I'm first going to open this system element in its own window. This is going to make it easy to come back to. I'll go ahead and minimize this now, and we'll switch over to the requirement class. Now when I parse the document, I had Core bring in every piece of information in that document. See all of these debris elements? Sometimes we can remove those, and sometimes they are golden. Debris 12 is a great example of hidden gold. It contains a mission statement for my system. Let's copy that and paste it over into the mission attribute on my system component. Here's that element we had in the background, and this is the mission. There we go. Now that I've captured that, I can clean up this debris element. I'm choosing to delete it. You could just move it into a subfolder to get it out of your way if you prefer to keep your debris. I'm going to go ahead and delete it today, just using the delete button up at the top. Now let's keep looking at the debris and deciding what to do with it. Now this is where I like to start after parsing a document. You can have the document parser only create the requirement elements, and this would be for statements that contain shall, will, or must, or any other keyword you designate. Now I like to bring in everything, and that's because it makes it easier for me to leverage things like the mission statements that are often included in source requirements documents, but don't necessarily have one of those shall, will, or must keywords. Now debris 11 is actually a reference to a document that has information on local governments. I can transform this into an element in another class, and I'd like to make this a document. So as I do this, the first thing I'm going to do is just copy the name here and paste it into the name field. So now I have this document named Zoning Regulations. And then to transform it to a document, I just drop it onto the document class. And Core is going to confirm that's what I want to do. I'll say yes, and it's done. Now, when it's time for me to go back and work my documents, I can do more with that. Moving them over there now leaves those breadcrumbs for me in the document class so that I don't forget to go deal with them. Now, debris 9 and 10 are also documents, but they're different. If I look at debris 9, I'll find it references the source document itself. Here we see that in the description field. Now I've already created an element to represent that. I did that when I parsed the document. So I'm just going to go ahead and delete this one. Debris 10 is another regulatory document. Let's move that over to the document class in the same way. Sorry, I'm having a little trouble with my mouse there. Got it. Rename it and drop it onto the document class. Now I have those and can go work with it again later. Debris 8. This was a header for those documents. Let's delete it. Now I can see here from the numbering that debris A.1, .2, and .3 are decompositions of A. Let's take a look at A. Now anytime the parser sees a paragraph, which is what it brought in here, it creates an element to represent it. Then it decomposed that with an element to represent each sentence contained within. And you can see down here it is refined by A1, A2, A3. And each one of those contains just one of those sentences. Let's see what this paragraph actually said. This looks a lot like a description statement for my system. So I'm going to go ahead and move that over to my system level component. Again, we had that open in the background, and I'll just paste it right here into the description field. Now I'm glad I had that information to capture it, but it's not really a requirement. So let's delete it and its children. And I just used the shift-click method to capture all of those, and then the delete button, and it will get all 4 for me. Okay, we're making some progress. Let's take a look at the rest. Debris 1 is just a header. Doesn't give me much Debris 2, again, not a whole lot of information going on here. Same for debris 3. Let's make them all go away. Okay, we're almost done cleaning up from the parsing. I can see that scope, applicable documents, and requirements are all just headers from my source document. I'm going to clean up those headers too. Here we go, our source requirements. Now some of you may be wondering, if I was just going to delete all of the other stuff, then why did I bother to create them in the first place? And again, it's because no computer algorithm is perfect, and some things just require a human. VITEC's position on this is that we'd rather give you everything from your source document and leave a few things to clean up than to omit information that you might have needed. Still, we give you choices on this. If you want to parse in only the statements with the shall, will, or must keywords, then you can do that. And you can refer to my screencast on the document parser to help with that. So here is the actual starting place. The first thing I want to do is to set the types on all of my requirements. I'm going to switch over to table view because it's good for this kind of bulk editing. That happens right here in the toolbar with the table view icon. All right, here we go. Now 3.1 is refined by all of the other requirements. And since it would contain multiple, I'm going to set this type to composite. We'll use composite anytime a requirement is or should be decomposed. In this case, this requirement is already decomposed by the others, so there's nothing more to do here. 3.1.1 contains this magic word "and." That usually means we have a composite requirement, and that is definitely the case here. Anytime we have a composite requirement, we want to go ahead and decompose it down to the leaf level, a single verifiable statement. I'll switch back to list view to do this, using the icon in the toolbar. Now I think the requirements diagram is a great place to do this. So I'll start there. Holding down Control again, I will drop New Requirement onto Menu. And I'm going to name this Burgers. Let's keep doing this for fries, shakes, and chicken. While I'm here, let's go ahead and number these elements. I'm just going to right-click on the parent and select Renumber Element. It's going to suggest a numbering scheme based on the existing numbering. And so this is saying the number of the parent. And then if I click OK, it will renumber the children. And I can see that when I switch over to list view that burgers, chicken, fries, and shakes got a number that implies the decomposition. And we can also see that decomposition here. Now, I really should fill in those descriptions, and again, table view is a great place to do this. So let's work a little copy-paste magic. The menu shall include burgers, chicken, fries, and shakes. Now, we need to go about setting the types. Sometimes I'm not sure which type to use. And this was definitely the case here when I started to work on the sample. I wasn't sure if this was functional or a constraint. And a few years ago, I asked one of our SEs for a description of each of these, and I keep this list handy. Let me show you my list. This is all of the requirement types with a short description. If you would like to get this list, I'll be posting it, actually it already is posted on the knowledge base in our website, or you can just email our support team and I'd be happy to send it to you personally. Now I see here that functional requirements are something the component must do. That's not what this requirement is telling me, I think. Constraint requirements here are usually associated with components, and the menu sounds like a component, so I'm going to go with that. We will set all of these to, let's set the parent to composite and the children to constraint. There we go. Now while I'm working these, I'm also going to work the origin, and when I have requirements that are just simple decompositions of a parent, I go ahead and set them the same. In this case it's going to be originating. Oops, there we go. All right. Now the next requirement is a bit trickier. It's the one for the color of the building. And this is a great example of when the presence of the word "and" doesn't necessarily mean you have a composite requirement. In the case of the menu, I can do chicken and burgers and fries, etc., without one of them undoing the other. In the case of painting the building, if I paint it red and I paint it yellow, I have a yellow building. I need a yellow and red building. So this really isn't a composite. I'm going to mark it as a constraint because it's telling me my building can't be purple. And we already have the origin set there. Now 3.1.3, eat in, take out. This is definitely a composite statement, even though it doesn't say and. I have to have eat in and I have to have takeout service. So let's go to the requirements diagram to decompose this again. I already have that element selected. I'll click on requirements. Oops, I'm sorry, I'm on color of building. Now I'm on eat in, take out, and we have requirements. So let's add those. Again, I'm using the control method, so I'm holding down control while dropping this on. So we will add eat in. We will add take out. And for good measure, we will renumber. Let's add some descriptions back to table view. Provide eat in service. Provide takeout service. I think these are definitely functional. It's something my system must do. And again, I'll set the origin to originating. Moving on to 3.1.4. Customers will place orders at the counter. No waiters or waitresses. I think that last part, telling me what I can't have, that definitely makes it a constraint. 3.1.5. I can have 75, but I can't have 76. Again, that sounds like a constraint to me. Now the next one tells me how fast we have to serve customers. From the time they walk into the door to the time they place the order, we have to do that in 5 minutes. I think this is a performance requirement, but let's check my list of types. Performance. And it has an associated prepositional phrase that describes how well, how fast, etc. That's spot on for this. So let's set this to performance. And taking a look at the last one, again, it's telling me how fast I have to do something. So that's also a performance requirement. Now we've made a lot of progress. Now, when I was working through this, I went ahead and set these origin fields. And while I had those drop downs, you may have noticed some other options. specifically derived and design decision. Anytime I see nil, I know I just haven't addressed it and I need to go back and fix it. But derived and design decision are things that we need to talk about. So let's take a minute and define those. You'll use design decision when the requirement changes as the result of a concern. I'm going to show you that in just a minute. You'll use derived for one that is further refined from a higher level requirement, or any requirement that results from choosing a specific implementation or system element. In a sense, all requirements are derived from the system need, thus the derived distinction often tends to have little significance. We've now taken a first pass over our requirements. We cleaned up the debris, then we decomposed them down to single verifiable statements, also called leaf level, and we set the types and origins. Some say this is when the real requirements work begins. Now, most anyone could do the decomposition of these requirements to recognize the composite statements and bring them down into single verifiable ones. Now, someone better versed in restaurants might see a problem with the requirement that says food has to be ready just 4 minutes after ordering. I worked in restaurants for a long time, and I know that chicken just does not cook that fast. Let's go ahead and capture that as a concern. So I'm going to switch over to list view. Food serving time shall not exceed 4 minutes. And it generates a concern. So I double-clicked on generates and it opened this dialog for me. I'll go ahead and click on concern. And my concern is that chicken takes too long to cook. We'll call this cooking time and say OK. Let's add a little bit of detail here. So we'll open up that element. And I'm going to cheat here. I have this text on another screen. There we go. Chicken takes longer than 4 minutes to cook. That's our concern. And so we should offer a few alternatives. Now, there are some assumptions here. This assumption is that we're maybe using chicken breast, which definitely takes longer than 4 minutes to cook. So let's offer some alternatives. Again, I'm just going to do some copy-paste magic so you don't have to watch me type. We can pre-cook the chicken, then reheat it. We can pre-cook it and keep it warm until we serve it. Or we could serve chicken nuggets, which easily deep fry in 4 minutes. So now I've captured this concern, and we can decide what to do about it when my review team makes a decision. And they can capture that decision here. They can also capture their rationale. Let's go ahead and do that. So here is our decision. We are going to serve chicken nuggets. And the reason why, if you've ever microwaved chicken, you know it has an odd texture. Holding the chicken at cooking temp for any period of time can cause it to dry out. And so chicken nuggets are our best quality option if we have to adhere to the time. So that's the route we're going with. And we've captured all of those thought processes here. Obviously, this would take you longer in a real-life scenario. You'd have to go out and talk to your stakeholders and come up with some alternatives. You could even consider changing the 4-minute requirement. But in my case, we're a fast serviced restaurant. That's really what we're all about, is fast, the best quality we can do fast. So we're going to serve chicken nuggets instead. Now, after we've done this, we can create a new requirement so that we verify it later. Sorry, I should have left this concern open. So here we are back in the concern. And then it results in, I'm going to click results in, a requirement. And we're going to call this requirement chicken nuggets. So now we have some traceability from our food serving time through the concern and into our chicken nuggets. But I have this chicken nugget just kind of hanging out here. I want to go ahead and relate it to my chicken requirement. So I'm just going to grab it and drop it on chicken. And Core is going to suggest for me the ideal relationship, which chicken nuggets definitely refines chicken. So we'll click OK. Now let's take a look at the requirements diagram of my menu. We see here at the first level that shows everything we serve. And then we see that chicken is actually refined by chicken nuggets. Let's go ahead and set the type and origin on chicken nuggets. So our type is going to be design decision. I don't know why I don't see it there. I'm sorry. The origin is design decision, and the type is constraint. Excuse me. There we go. So we just worked a concern. Concerns are things we think we can address or fix in some way. And as you evaluate your requirements, you may have many more of these. You may not have any at all if your stakeholders spend a lot of time on their requirements before they gave them to you. So whether or not you do this and how deep you do your concerns is going to relate to the individual nature of your project. The risks are things that we probably can't fix or address, and they represent uncertainty. And that's uncertainty of achieving the milestone or the performance parameter or whatever it is that the requirement is asking us to do. Now we have a requirement that asks us to take an order within 5 minutes of the customer entering the restaurant. That's this one here. Entry to placing the order, not more than 5 minutes. This is definitely a risk. There's some things we cannot do to mitigate it. But when a bus with 30 soccer players pulls into the parking lot, we're probably going to miss this one. So let's capture that. This requirement causes, I'll double click, a risk. We'll call this order time. Click OK. Now let's open it up and go ahead and get ourselves a description so that we know a little bit more about what I'm talking about. Again, some copy-paste magic so you don't have to watch me type. Large rush of customers may cause us to miss this. Now notice that there's a whole lot more information here on the risk class. We have a status so we know if we've done anything at all. Closed, rejected, there's some options there. We have a status description so I can keep some notes here, and a mitigation plan. These can be used to capture your work on the mitigation of this risk. Now, I've only scratched the surface today. I could spend days, weeks on these requirements, but I encourage you to resist the urge to go too deep, too fast. One of the things that we teach, and it is expanded on in our primer for model-based systems engineering, is that if you go too deep, too fast, you may actually run past a problem or cause a problem that would be more expensive to fix later. So you definitely want to do this in layers and through the STRATA methodology that we teach in our primer. So today I stop here. My next task, and maybe a possibility for a future webinar if Katie can twist my arm, is to define my system boundary and consider how my requirements specify the high-level system behavior. So that wraps up everything I've prepared for you on decomposing your requirements and getting yourself ready to go to the next step. Katie, I'll turn it back over to you for questions.
Okay, thank you so much, Bethany. And let's see. So if you need to leave the webinar now, we understand, but I did want to go ahead and ask you that you please fill out the survey that pops up on your screen when you leave. So Bethany, here's our first question. It says that you started with the requirements already in core. If I needed to learn how to do that, where would I go?
I would love to help you with that one. We have a screencast library where I have made some videos that you learn how to do some of the things that you need to know in your first few days using core. So this is our website. If you go to resources, then screencasts, you will find some collections here, and this Getting Started with Core Commercial Edition will walk you through things we think you need to know in your first day or two. And Document Parser is included in this because it's honestly one of the first things people do. People frequently parse a document before they even try to save data. So we've offered this to you here. If we have any university folks out in the audience today, we have specialized this entire series for the University Edition, so you want to make sure that you grab that set if you are using Core University Edition.
Okay, thank you. And I'll go ahead. I've got the direct link, so I will chat that out to the group. And let's see. I've got a question here. It says, based on your last statement, is or will the system context diagramming be a feature of core?
Okay, I'm actually going to try to first interpret what you're asking here. And I think what you're asking is, well, gee, it's great to model your system, but what about modeling the environment your system lives in? And if that's what you're asking, then CORE already does that. You can model your system on the context level, on the physical side, as well as on the behavioral side, and those things are already available to us here. And in a sense, I already kind of started on that. If we look at my component class and go to System Context, let's look back at that structure BDD. We have here our context, and within it is my restaurant. But maybe we want to go ahead and model our customers, because they're definitely in the context. I'm using the Control-Shift method again, and we'll call this customer. And I mentioned during my presentation the food supplier. That's definitely in my context. I can't control that. That's not my system of interest. So I can go ahead and start working on the physical architecture. And then the same thing on the functional side. All of that is available to you. And when we're talking about modeling and layers, this is a key place you want to take a look at layers to make sure that you keep your context all together in one level. And don't accidentally put the restaurant kitchen on the same level with customers. We would decompose fast food restaurant with the kitchen, with the service counter where people place orders, and the dining area and such. And so I can go ahead and get started on those layers and just see those kinds of things. If I've misinterpreted the question, please do send another chat message back to Katie and clarify.
Okay. I don't see anything else right now, so we'll see if anything else comes up. And let's see, I've got a question here. Why do you keep the composite statements? Wouldn't it just make sense to replace them with the leaf level requirements?
Okay, that's because of traceability. When I like to really keep track of everything that we've done. And so if we look at my document class and look at my requirements source document, I need to make sure that it, documents my requirement, and I'll pick my top level. Okay, so now I can trace where did my relationship go. I must not have double clicked. There we go. So I can see that my document documents my specific requirements. And here, now we see how this traces down. I can see that from my source document, we have all of these. And this preserves the document in a sense. Now, if I want to see more, this helps me understand the evolution of my requirements. And so we had this menu one, and then upon examination, I realized this had to be decomposed. Same thing here. And this just helps to preserve that and give you full traceability into your into the history of your model.
Okay, thank you. Yeah, when I took our training class on CORE, I asked a similar question to what we got here, and the instructor really emphasized, well, when you're doing your project presentation and you're designing your whole system, and says, well, why did you do it that way? You want to be able to say, well, that's why, because chances are you've forgotten at that point when you get really deep into your system design. So thank you for pointing that one out.
Yeah, you couldn't be more right, Katie. Part of the benefit of using a tool like CORE is it causes you to leave the evidence of your work. And by making sure that you complete information like the type fields and the descriptions and the rationales, leaves information for you, because some of these systems that our customers are building take years, a decade in some cases, that people are working on these. And you're going to forget. There's just very few brains out there that can hold all of this in. And making sure you fill all of this out as you go is really making your model part of your system documentation.
All right, well, thank you so much. That does look like that's the last of the questions that we have today. However, if you start to get into the tool and you have any additional questions for Bethany, please don't hesitate to shoot an email to the support@vitechcorp.com email address. And you can also post your questions and comments on the Vitech LinkedIn group page. I am sending out the link to that now. Unfortunately, it is kind of an unwieldy link, but that should get you straight to our group page. I want to thank you all for joining us today. Please keep an eye out for our next webinar invitation. We'll be sharing the details of our recent report, the ROI of CORE. We're going to be doing that on December 4th. To register, visit the link that I am sending out through the chat window. And at the conclusion of the webinar today, a survey will open on your screen. Please take a moment to give us feedback on today's presentation or let us know what topics you'd like to see covered in future webinars. Once again, thank you for joining us and have a wonderful day.